So it is very important for our application to let the user feel safe while doing this operation. We should implement a series of steps that the user can enjoy. Starts with inputting all the key pieces that a transaction is composed of, and then finishes with a confirmation. So basically the user reviews it and says, okay, everything is fine, I'm sure that I'm sending the right amount of funds to the right person, so let's go on with it and let's confirm it. So, hi everybody, welcome into our actually first talk. We are pretty excited to be here and to show you guys our journey that took off from something that we are familiar with, being React Native of course, and ended up in a fascinating world called Web3. We've been developing React Native application for quite some time now. Myself has been developing apps for like more than 3 years, more or less, while Umberto for almost 6. And we hope that by sharing to you this journey, you will love it as we did it and try to develop something using the same technologies, or maybe, you know, release actual apps using Web3. Let's start, before diving into the technical stuff, with a quick question, that being why? Why Web3, why not any other topic much more related to React Native itself, maybe animations, a cool library, native modules? Well, it comes down to what we think Web3 will be in the future and what we think Web3 it is actually already. For us, it is an amazing technology, it is growing quickly. A lot of projects have been built using this technology and have already been shipped in the outside world. A lot of users are using it and the adoption keeps rising. Since the first introduction of Bitcoin, nowadays we have got many kinds of blockchains targeting different needs by using and implementing different capabilities that you can leverage. And many companies have been harnessing their power to develop amazing products that, of course, end user can leverage. We are explorers, we define ourselves as explorers, and while surfing the internet, fueled by curiosity, of course, curiosity is our main beacon of light that shines, of course, light in this darkness that's an unknown world to us. And with curiosity as a tool in our coding belt, we went on and took a deep dive into this amazing world and try to understand its point of view from the end user that has a lot of projects that he can use and enjoy and play with, such as applications, websites, and many more cool things. And then we kept going and went with this side of the developers, so the actual stuff that we enjoy or maybe hate, I don't know, it kind of depends. They being libraries, implementations, theoretical stuff you should know. And we quickly learned that there are two sides of the same coin. The first being something amazing, something also innocent, I would say, tied to the user eye. We call it a galaxy of wonders. This technology is a much more complicated ecosystem that one could think of. There are many different kind of words that quickly arisen since, of course, the first introduction of Bitcoin. We have got, after the release of the concept of a smart contracts, many kind of fields in this industry, they being decentralized finance, gamification, metaverse. There are a lot of things that you can play with. One could simply lose himself trying to understand their bits and pieces, trying to learn how to develop something specific for this kind of field. They've got different requirements, different technology stack that you should be aware of. And talking about technology stack, we can finally see the other not so kind side of the same coin, it being something that at first scared us, because it can appear to be pure chaos. Behind an implementation of a blockchain there are concepts that can be tricky to learn at first. They being cryptography, algorithm, the concept of a block, what's behind a blockchain, how you interact with a blockchain, what you should use, what can you implement, and keep in mind that there is one particular thing, one particular concept that we as a front-end developer using React Native should keep in mind, that being the crypto module. It is right here, and it is something that can be really tricky. We will see in a couple of slides why. And after surfing the internet and grasping what we could build using blockchain and what we should be aware of, we went on and started to look around for actual resources that us, the developer, can leverage, use, and take inspiration from. So of course we went in a lovely website that I'm sure every one of us use every day, it being GitHub, our daily dose of open source resources and open source material. Luckily, blockchain is a field that offers a lot of open source material, so that's a win for us developer. We can enjoy a lot of tutorial, guides, code. There is a saying in blockchain that is don't trust, verify it, and of course you can do it using GitHub. So we went on, and on GitHub was our turning point, because we learned what we could build, we learned what we should be aware of, and then it was time to find some project to take inspiration from. So we decided to try and look around for projects that we played with, and we found their GitHub repositories. There are a lot of repositories. It kind of depends on what you're looking for in this industry, in the blockchain itself. Of course, it is correlated to the world that you are trying to build apps on. For us, it was the concept of a wallet. So we went on and looked for some of them, and there are actually two repositories that we took inspiration from, they being Uniswap wallet and Rainbow Me wallet. We will see later what's a wallet and how you can create it, basically. In looking for them, we asked ourselves, of course, this lovely question: who's out there building stuff? Who's behind implementation? Do we have to do stuff from scratch? Is there any library that we can implement? Is there any code that we can leverage for ourselves? Because this was a learning experience first. And of course, we took inspiration from Uniswap wallet, but we saw lots of projects behind the blockchain ecosystem. There are also private companies like Coinbase, for example, and there are many other kind of companies and entities that are building stuff with blockchain. Now it was time for us to decide what kind of blockchain we could leverage and what kind of library we had to implement. To keep it simple, we decided to leverage the same blockchain and the same library that those two projects that we talked about, Uniswap wallet and Rainbow Me wallet, were using, they being Ethereum and EthersJS. Ethereum is a well-known blockchain. It has been around since a lot of time. A lot of projects have been built upon it, are currently leveraging its network. And of course, it is developer friendly, so you can search online a lot of material that can guide you and help you develop something using it. And EthersJS is a specific library, one of the many that you can implement with a JavaScript environment. And we chose it for a specific reason that we will talk about in the next slide. Now I'll leave it up to Umberto that will explain to you guys how we structure our talk and what will be the next step.
Thanks, Mirko. Okay, first of all, we created a roadmap to understand what we need to achieve our goal to create this proof of concept app. And we divide the roadmap in 4 steps. The first, the setup, where we decided the architectural purposes and which library we have to use. The second is the wallet, where resides the creation of the wallet with encryption key and all necessaries to connect to our blockchain. Provider, where effectively we connect on node that is synchronized with blockchain. And transaction, where effectively made some operation on it. So let's go deep in the first step, setup. As we said before, we add headers, that is a library that permits us to use methods from wallet to transaction. So we have a wallet, provider, and transaction all in headers library. And we choose the version 6.5 at the beginning. Also, if missing React Native support. But why? Because EthersJS use some crypto module that is not fully compatible with React Native. So headers fallbacks to crypto.js. I think everybody, some of you knows crypto.js that is written in JS and works obviously in JavaScript. And is a little slow on React Native. We need something to solve this problem. Headers 6.5 offers some overrides method of crypto functions, so we need to implement it and try. We did it, and creation of wallet works very well. Only 300 milliseconds to generate a wallet instead of 15 seconds of crypto.js parts. So what could go wrong? After we try to connect to provider, and sometimes you forget that React Native isn't a browser-like environment, neither a Node.js one. Crying React Native developer. Guess who crying? We miss some parts because some functions of Node.js are not present in React Native. So the provider doesn't work. We need to think about it and try to solve. After a couple of hours of brainstorming, we try to let's patch things up. So we divided this in 3 different steps. Downgrade to another version that is fully compatible with React Native. Add the React Native quick crypto that we see after. And patch some headers crypto module usage. So go to the first. As I said, we installed headers 5.7.2. It's a version fully compatible with React Native. But also we have to add one other library that is called headers project shims. This library is also developed by headers, and it contains some missing environment functions that we need in React Native to do some methods on our blockchain. After this, we try again. Finally, provider works, so was a little very good. But again, the encryption method to create wallet takes a lot of time. Again, 15 seconds to generate a wallet. So we found another library, React Native Quick Crypto. This library exposes the same methods of crypto.js, but the difference is React Native Quick Crypto is written in C++. So we have more efficient and more performant encryption method than before. So we try to add it, and after we have to edit this bubble config and add this plugin module resolver. This plugin means that if you have, for example, an import some methods from crypto, you can alias it to React Native Quick Crypto. So every time you import something, module resolver translates this with your library that is written here. After this, you can think that all can work very well, but again, it doesn't work. At this time, we don't know how to do next, because all of this was enough to work. No? Because this is an alias. If headers use crypto now is linked to React Native Quick Crypto, so all has to work. But no. So other 3-4 hours of researching on GitHub issues this time, and we found on GitHub issues some patch. So we understood that we need to patch one module of headers. In particular, the module is called headers project pbkdf2. We have to override in node modules all codes that is present in this file with these 2 lines of code. So we spent a lot of hours for these 2 lines of code. But finally, after patch package running, we did it. Finally, all works. So creation of wallet takes 300 milliseconds and provider connects immediately. So finally, we have a solution. So now I give the roof to Mirko to
and keep remember that we kept crying during the entire flow of working. So that's really important. So as Umberto said, we finally patched things up, and it was now time to get things done and start using header.js methods. First off, we had to, of course, create a wallet and implement the required features of a mobile wallet application. Let's start with what's a wallet, why you need it. Well, with Web3 technology, through a wallet, you can basically interact with an account in such network that you choose, of course. We chose Ethereum. And it takes care of holding key pieces of information that you need in order to properly authenticate yourself, move funds between the network, and of course also to display some information that you need to receive them. So now that we understand a little bit better what is a wallet and why you need it, our mobile application should implement 4 key operations to properly function and to properly set up a wallet, they being the create method, the store method, the restore, and the import one. Starting with create. As we said, a wallet holds key pieces of information, they being the following one, from the mnemonic phrase to the address. Starting with the mnemonic phrase, it is the key component that we said earlier we wanted to try and use, and therefore we had to choose EthersJS as our library, because it is one library that actually lets you create a wallet from a mnemonic phrase. A mnemonic phrase is nothing scary, just a random string of words that basically make up your backup. So without it, if you for some reason delete the app or lose access, you probably will lose all your funds. So as our job as developer is to show these words to the user so that he has time to properly check them out and of course store in some place safe, because if they are stolen from him, anybody else using an application implementing the same standard would be able to leverage this mnemonic phrase and get access to a wallet. Then, from the mnemonic phrase, we get a private key. This is another key piece of information that should stay private. You can think of it like a password with which you authenticate and sign off every transaction. So every time you need to send funds around the network, you need to first authenticate it, to confirm it, and to do so you need the private key. From the private key, we can derive a public one using an algorithm that I will not try to pronounce, it's complicated. There is an acronym that you can read for yourself. It is not nothing scary, it is not alien stuff, simply an algorithm that lets you derive a public key, and it's one way. So it means that theoretically, you can't derive a private key from a public one. If you search online and look enough, you will actually see that through quantum computing, you are able to break this kind of encryption, but this is complicated stuff. We will leave it for the math guys out here to figure out and to safely implement stuff that we can leverage to avoid this kind of problem. From the public key, finally, we are on the safe zone. From here on out, you actually have to share the information, the next one, to receive funds and to let your friends or any kind of entity that maybe wants to send you money so that they can actually do so. To derive an address from a public key, we simply use an hash function, another kind of mathematical implementation that, of course, we still leave it to the math guys out there. With EthersJS, we have got, of course, a method that we can implement, that we can leverage, it being a static method from the wallet class. It is create random. It takes care of everything, and through this method we actually use the function that Umberto mentioned earlier. That function that we had to patch up was the one that we need to use to create a mnemonic phrase. So that's why we needed this patch. Otherwise it would take up to 30 seconds, 15 seconds, something like that to create the wallet. So it is not acceptable from the user experience point of view. That said, now that we have got a wallet up and running, the user can actually see all the key components that he can share, it being the address, the balance of the funds that he holds. It is now time to implement a proper way for the user to go back in the app maybe the day later or maybe an hour later, and find his wallet up and running again, because we said that the only way, one of the ways to use a wallet is with the mnemonic phrase, but we can't let the user input every time a random set of words, because it isn't a nice user experience. So we can leverage actually something that all devices have at our disposal, they being a storage, key pieces of technical stuff that we are able to call from the JavaScript side, they being the keychain and key store. Through them we are able to store the private key, it being the password to the account, and of course it isn't enough, because bad luck happens, maybe the user phone gets stolen, so if anybody can crack its password or can get access to it, he would still be able to open the app and use all the funds freely as he wishes to. To avoid this, we can implement standard ways to achieve authentication and authorization, they being fingerprint, face recognition, one-time password, all the kind of mixing that we can think of to ease these kind of security layers for the user to enjoy and to implement as he wishes for. So now we've got both the way to create a wallet and both the way to store something that can help us initialize it back once the user go back to the app, and to restore a wallet using the private key, we are able to do so using the wallet constructor. Of course, of EthersJS itself. We simply read the private key, but we read it, and then we input it to the wallet construction, and we've got our wallet up and running. The last key operation that we can implement, but not the least one, not the least important one, it is the import. This is something that you should take care of, because there are many kinds of wallet, many kinds of services that someone can use to create a wallet. So we should take care of the kind of user that it's the first time that wants to try Web3 technology, so doesn't have an account already yet. And then we should also take care of the kind of user that already has an account, and that's of course generated using a compatible standard, it being the mnemonic phrase flow. So someone that has already got this series of words and therefore can input them into our application and enjoy its wallet up and running. So with this we can end this chapter related to a wallet. We found out how to create one and how to properly set it up and running. And now we will have to talk about a key of information that lets us interact with it. I leave it up to Umberto to explain it to you.
So we speak about provider, and everybody knows that if you want to call something out of a mobile app, it's some backend. You need a backend to call something. Also for the blockchain, is valid this concept. But in blockchain is not called backend, but is called node. This node is a server that is synchronized with blockchain and provides some methods to access. Exists two ways in this case to implement one node, and the first is develop one node, so one custom node. But in this case we have three different types: light, full, or archive. I don't want to go deep in this because it's too much difficult. But for example, if you want to develop a decentralized app or a complex wallet that needs to access transaction of years ago, you need to develop an archive node. And this is not the only blocked way, but also you need to know the hardware and bandwidth necessary to develop one of these. And every type of node has different requirements of hardware and bandwidth. But exists another way. So the first, what should we use? I forget this. What should we use? Neither. Neither of the three before. We have to use another way. The other way is to use the services online. Exist some services online like Firebase or Amazon Web Service that can provide for you one node that fulfill your purpose. This not bad. So Exists also another service that is called Quick Node. Quick Node, that is the easy way, no? Because if it's like Firebase or like Amazon, it's more simple that develop one entire node. So Quick Node is one service externally that provides you a dashboard that you can edit, configure it to your purpose, and also provides two different protocols, one HTTPS and one is WebSocket. For our purpose, we choose obviously HTTPS because it's a proof of concept. We want to try to make a transaction, so it was enough, but nothing changed if we want to use WebSocket. We choose Quick Node, and now it's the moment then we have to connect to our headers. So headers provides one class that is called provider, and this class permits to instantiate one method, instantiate more methods that permits you to read from your blockchain. So you can, for example, get the balance, get the transaction, or also send a transaction. The provider accepts two arguments. The first is provider URL that is Quick Node in this case provides to us, and the second is provider network. Provider network is based on Ethereum. Ethereum offers a lot of network. In this case, I want to divide production and test, sure. We use obviously testnet. We choose Sepolia,
yes.
Sepolia network, also to not to pay too much gas fee. We don't want it's only for testing. And after to connect the wallet, to connect the provider to the wallet, we have to launch the second line code and instantiate the new wallet. And this wallet is the wallet that we have to use in all apps. So now, again, it's turn of Mirko.
All right. Thank you, Umberto. So finally that we've got our lovely wallet up and running and the provider as well, so we can interact with our lovely node, let's talk about transaction. What are transactions? Basically, you can see them as an exchange of value. In this case, between Elon Musk and Mattarella, but it can be anybody else in the world. And also, it can be any kind of entity inside the blockchain. So you can either see the transaction as an exchange of value between you and one of your friends, or between you and a decentralized application that we mentioned earlier, they being application running on a blockchain that offer you some kind of project up and running that the user can play with. One key piece of information you should know about a transaction is that technically, it is very hard, and by it I mean very, very hard to revert it. So once a transaction gets validated by a network, it is set in stone, at least in Ethereum. And to revert it, it is quite a challenge. You obviously have to have some malicious intent. You are able to do so, but trust me, it's really difficult. You can look it up. You should have so much computational power that I think you need a lot of money. I don't have that kind of money, unfortunately. I'd like to try, but it's feasible at the moment, at least. And so this transaction also, as Umberto mentioned earlier, costs something. As in the fiat world, as in with euro, USD, whatever kind of currency you have at your disposal, you have to pay something to the network itself. The network is composed, as Umberto said, of nodes. They validate the blockchain, they take care of the blockchain for us, so we have to pay a fee to them to include our transaction, our exchange of value, and persist it inside the blockchain. So it is very important for our application to let the user feel safe while doing this operation. We should implement a series of steps that the user can enjoy that starts with inputting all the key pieces that a transaction is composed of, and we'll see it soon enough, and then finishes with a confirmation. So basically the user reviews it and says, okay, everything is fine, I'm sure that I'm sending the right amount of funds to the right person, so let's go on with it and let's confirm it. Starting with the first step, EthersJS exposes a method that we can leverage. Let me just say though that this is one of the methods that you can use. There are actual short ways that you can implement. We chose these kind of steps to properly show you guys how you can structure a flow that's actually safer for the user. The first one being populate transaction. This kind of method creates a transaction object and takes care of some of its properties that without it you should know and of course also set. Behind this method, our wallet queries the provider for some information that it needs to set the properties to. For example, the gas limit. We'll talk about it soon enough in a little second. First, let's focus on the two key properties shown here. The first being the to property and the second one being the value. The to stands for the receiving address. So as we said earlier, the only way to, it's not the only way, but the standard way to move funds is to think about entities inside the blockchain as addresses. So you need an address as a standard way to send money. There is also another kind of way. We have not yet implemented it, but there is. So you have two ways at the moment. The first one is this address, so a user should have an input to properly set this address, and they change depending on the kind of blockchain you are trying to implement. So to make it easier for the user, you should know what's the structure of the address of your blockchain. In the case of Ethereum, it has a prefix that's 0x, and also a length, but of course you can check out all the requirements and all the necessary steps to ensure a correct validation. So after the user inputs the address and we validated it, then we've got the second property, that's the value. The value stands for the user amount, so he should have also a proper input to set how much money he wishes to send to another address. We talked about the gas limit, and it is also a third piece of information that stands for the cost of a transaction. It is a group of properties, actually, they being all related to the cost of a transaction, since a recent change in the way Ethereum works. Now you've got actually different properties that you can set, but even EthersJS documentation encourage you to leave it as it is for the user to set them up using the wallet itself, because it's not that easy to do so, and not many users have the knowledge to properly set the cost of a transaction so that they don't lose the transaction itself, so that the transaction doesn't fail, basically. That said, let's go back to the value. This is important to us because with Ethereum we must think about the native asset blockchain, so the funds itself, as named units to properly understand the transactions. These named units, the main one at least, are Way, Gway, and Ether. Way is the standard named units that we can think of and that EthersJS needs when thinking and setting up a transaction. While Gway stands for, the G stands for gas, and of course we can use it to talk about cost of a transaction itself. And then we've got, of course, Ether. Ether is the kind of named unit that the user wishes to input in his application. Therefore, we need to take care of the conversions between them, and to do so, of course, we don't have to implement some version from scratch of the logic that we need to do so. We have got headers that cover us and exposes some methods that we can use. They being parse units and format units. The first one takes in a string and basically converts it to a named unit whose type is big numberish. Big numberish is a union type of string, number, int, bytes. There is a lot. Basically, what you need to know about this is that big numberish is the kind of type of value that EthersJS needs that works with, so it needs for the transaction, while format units does the opposite, basically takes an amount coming from the blockchain, a value coming from the blockchain from EthersJS, and converts it back to something that the user can understand. Now we've got some examples. On your left, you've got user-chosen amount in Ether. This flow represents the usage of parse units. We can use parse unit, as we explained, to convert something that's coming outside of the application, so from the user itself, back into something that Ethers understands. On the right, we've got the opposite. We have got something that EthersJS outputs, and we need to convert it back to the user. When do we need this? We need it throughout the entire usage of our application. First, from the dashboard, for example, to show the right amount of funds that the user has. And of course, throughout the entire flow that's sending the transaction itself to the network, we need to accept Ether as an input and of course convert and show the right amount of information to the user, like the transaction cost and anything else really. So now that we have got named units covered, let's talk about how to properly send it, what we can use from EthersJS itself. We have got, as I was saying before, shorter ways or longer ways. We've got the longer one. Here we've got two methods. The first one is a signed transaction through the wallet object itself. Basically it encrypts the transaction with the private key, and you ended up with a hexadecimal strings. And that kind of information is the one that you need to supply to the other method, it being send a transaction from the provider itself. Basically, this send transaction sends your lovely transaction to the node that you've got at your disposal, and the node will then take care of it. From this operation, then you've got many other methods that you can leverage. For example, you can leverage a method that we didn't actually implement, but it can be useful. You can wait for the transaction to actually end, so you'll eventually block the thread, but you will end up having a user experience in which you will, if the user wishes to do so, make sure that to wait for the transaction to actually execute. I don't know when you could use it, but maybe for some project you will find a useful case. That said, after we saw how to create a wallet, how to input something from the user and the transaction itself, you can see the last part, so build it up. You can see the entire flow from the create random method, that's create your wallet, up to the send transaction that basically send. And with this, it completes our presentation. I hope that you enjoyed it. I hope that you loved it as we did, and maybe you will try to create something and send us your project.